Hello everyone, this is Mamatha Denukonda, working as assistant professor in EEE department. So in this presentation I'm going to explain about unit 1, which is introduction to electric circuits. Now the learning objective of this unit is to study the concepts of basic definitions of electric circuit, like what is a circuit, what is charge, and what is a current, what is voltage, etc., and to know about passive elements and different types of sources and various network reduction techniques. So these are the objective of this unit. the, these are the topics you are going to learn in this unit. Okay, now coming to the course outcomes, in the sense, after the completion of this presentation of this module, you people are can able to know all the basic definitions that I mentioned earlier, and you can also able to solve basic circuits and some complicated circuits, which is called DC circuits or DC networks. To solve DC networks, we can use different network reduction techniques. So after the completion of this presentation, you can able to solve this different DC networks using different network reduction techniques. Now coming to the contents, in this presentation I am going to explain these topics: what is electric circuit analysis and definition of charge, what is the formula of the charge, and what is current, what are different types of currents we have, and what is voltage and formula of the voltage, and next power and energy. So these are the topics I am going to cover in this presentation. So let us go to the main topic. Now coming to our unit name, the subject name is electric circuit analysis 1 part 1. In next semester you are going to learn the part 2 of this electric circuit analysis. So before that, I just give some brief introduction about uh, electric circuit analysis. Electric circuit theory and electromagnetic theory are the two fundamental theories upon which all branches of electrical engineering are built. Many branches of electrical engineering, such as power engineering, electric machines, control systems, electronics, communications, etc., are based on electric circuit theory. So therefore, the basic electric circuit theory is the most important concept or the course for an electrical engineering student. So that's why it is very necessary to learn this basic electric circuit theory in order to know in detail about machines, control systems, electronics, electronic communication circuits, instrumentation, etc. So that's why we are going to learn this circuit theory. And the basic electric circuit theory is very most important course and always an excellent starting point for a beginning student in electrical engineering education. And the circuit theory is also valuable to students specializing in other branches of the physical sciences, because circuits are good model for the study of energy systems in general, and because the applied mathematics, physics and topology involved. So this is the importance of the basic electric circuit theory. And in electrical engineering, we are often interested in communicating or transferring energy from one part to another part. To do this, it requires an interconnection of electric devices. That means energy transferring from source to load is dealing with a lot of network elements which are interconnected together. Okay, so in order to know about that interconnection part, in order to do the analysis part, we should know the basic circuit elements and what are the basic sources we have, so and so. So Coming to the second paragraph, here itself it explains such interconnection, that means the interconnection from source to load is referred to as an electric circuit, and each component of the circuit is known as an element. So this is the definition of a electric circuit. And of course, electric circuit analysis. Circuit analysis means it is the process of finding all the currents and the voltages in a network of connected components. So analysis means it is nothing but a finding process of finding a response. That response may be a current or voltage or power also. So this process is called analysis. We are doing this process in an electric circuit, so that's why it is called electric circuit analysis. So here the figure represents a simple electric circuit having battery and a bulb. So this battery is simply call it as a source, and this bulb we simply call it as a load, which are connected using a wire, right? A wire, and there is a switch closed here. Okay, so this connection is a basic electric circuit connection. Source and load are connected together. So if we find out a current flowing through the wire, or if we find out how much amount of current flowing through the bulb, how much amount of current coming from the source, nothing but analysis. That means we are finding one response. So that is what called basic circuit analysis, right? Now let us move on to the basic definitions, which is very essential to know or to do the detailed analysis of different electric circuits. One is electric charge, or simply call it as a charge. Next one is current, and next voltage, and next power and energy. So these are the basic quantities we should learn in order to solve a electric network, right? So coming to the electric charge, it is simply call it as a charge. First of all, the concept of electric charge is underlying the principle for explaining all electrical phenomena. Also, the most basic quantity in an electric circuit is the electric charge. I think we all experience the effect of electric charge. Am I right? Let me give an example. When we try to move our sweater, which is made up of wool, and have it stick to our body, okay, there we send some kind of charge, right? Or walk across carpet, etc. Some examples. So that means some vibe is there, right? So that is some examples. Now coming to the basic definition related to electricity, charge is an electric property of the atomic particles of which matter consists. Okay, let me explain in detail. We know from elementary physics that all matter is made up of fundamental building blocks. I think you know those are known as atoms, and that each atom consists of electrons, protons, and neutrons, right? We also know that the charge of an electron is negative, right? Charge of an electron is negative, and the proton is positive, and the magnitude of these charges is equal to, any guess? Okay, I will answer. Magnitude of this charge is equal to 1.6 into 10 power minus 19 coulombs. Okay, this magnitude is equal to proton charge and also electron charge, right? I mean the same magnitude. The presence of equal numbers of protons and electrons leave an atom neutrally charged. So each and every atom is comprises of electrons, protons, and neutrons. So each electron and proton is having some charge value, a magnitude. So that is the main property of each atomic particle. So and charge positive or negative is denoted by letter small q or capital Q, and it is measured in coulombs, which is denoted by letter C. So that is about the electric charge. Now coming to the next main definition, which is current or electrical current. This electrical current is the rate of flow of electrical charge through a conductor or a circuit element. As I mentioned earlier, there is an electric charge for each and every material, nothing but some atom. So if there is a flow of electric charge through a conductor with respect to time, okay, whether it is a conductor or some element, with respect to time there is a rate of flow of electric charge, then that particular movement of electrical charges is considered as a electrical current. Okay, so that is the definition. And the units of the current is amperes, denoted by A, which are equivalent to coulombs per second, because so there is a formula for the current with respect to charge and the time. I will explain in the next slide. Depending upon that formula, there is one more unit we have, which is coulomb per seconds, denoted by letter small I or capital I. So this is the formula. I is equal to Q by T, and Q is equal to I into T, and also small I is equal to small change in charge divided by small change in time, dq by dt. Okay, so that's why the unit we have is coulomb per seconds. And next, there are different types of currents we have. Two main types of current. One is DC, next one is AC. Coming to DC, when the magnitude of current is constant with respect to the time, we can say that is a DC current. Nothing but direct current. We simply abbreviated it as a DC current. Now coming to our unit name, the subject name is Electric Circuit Analysis 1 Part 1. In next semester you are going to learn the Part 2 of this electric circuit analysis. So before that, I just give some brief introduction about electric circuit analysis. Electric circuit theory. And next, one more definition we have is voltage. Voltage, or sometimes we call it as potential difference. Okay, let me explain it clearly. Charge moving in an electric circuit gives rise to a current, right? We already discussed in the previous slide, right? Naturally, it must take some work or energy for the charge to move from one point to another point, right? Without giving any energy, how it can move, right? So it must have some energy in order to do some work, right? For the charge to move between 2 points in a circuit from one point, let us take a point A and point B, the total work per unit charge associated with the motion of the charge between 2 points is called voltage. So that is what called the voltage. If there is a work done takes place in order to move charge from point A to point B, we call the work per unit charge is the motion of the charge between 2 points. We call it as a voltage. Thus the units of the voltage is volt, and simply it is denoted by letter V or capital V. And voltage is also called it as a potential difference. So that is what I explained earlier in the previous slide. A point and B point, if there is a work done from A to B, that it is denoted by VAB. If A is positive, B is negative. So otherwise, if B is positive, A is negative, we term it as a VBA. So finally VAB is equal to dW by dQ, work done per charge, where W is energy and unit is joule, and Q is nothing but a charge, unit is coulombs. So simply 1 volt is equal to, that means if the voltage value is 1 means, so there is a 1 joule of work is done in order to move 1 coulomb of charge, right? Or another unit is Newton meter per coulomb. So that is the formula of the voltage with respect to energy and coulombs. Similarly, like a electric current, we also have two types of voltages. One is DC voltage, next one is AC voltage. Of course, the definition is same, but in place of current, we simply represent as a voltage. If the voltage magnitude is constant with time, then it is called DC. If the voltage magnitude and direction is varying, if it is sinusoidally varying, then it is called AC voltage. That is simply represented by small v, just to show the difference between DC voltage and AC voltage. Next, coming to the power and energy. So these are the last main definitions that I am going to explain in this presentation. These two are interrelated, so that's why I mentioned in one slide. Although current and voltage are the two basic variables in electric circuit, they are not sufficient by themselves. For practical purpose, we need to know how much power an electric device can handle. I think I explained earlier, response means not only the voltage, not only the current. If we can say the response or the analysis is completed in a circuit, means the final thing we have to measure is power. Okay, so for that we also know that when we pay our bills to the electric utility companies, we are paying for the electrical energy consumed over a certain period of time. So thus power and energy calculations are important in circuit analysis. So that's why we have to learn about the power and energy formulas and analysis. So power is the rate of expending or absorbing energy measured in watts, which is indicated by letter W, and the power is denoted by capital P or small p. Okay, so simply we can define like how much amount of energy is consumed during some time period. So dW by dt, where W is work done, nothing but energy, dt means time, which is in seconds. So from this we can write the unit for the power, not only watts, which is also joule per seconds. Now coming to our unit name, the subject name is electric circuit analysis 1 part 1. In next semester you are going to learn the part 2 of this electric circuit analysis. So before that, I just give some brief introduction about electric circuit analysis. Electric circuit theory and electromagnetic theory are the two fundamental theories upon which all branches of electrical engineering are built. Many branches of electrical engineering, such as power engineering, electric machines, control systems, electronics, communications, etc., are based on electric circuit theory. So therefore, the basic electric circuit theory is the most important concept or the course for an electrical engineering student. So that's why it is. And also we have current directions. Here also a sign convention is important for power also. Let us consider ABC examples. If there is a VA 12 volts appear across here and IA 12 amperes flows through the element A. So that means the direction of the current is from positive to negative. That means the energy is being absorbed by the element. That means power is having positive sign, V into I, 12 into 2 amperes, 24 watts. If the sign convention is opposite to the current direction, then it indicates power or energy is being supplied. That means being supplied, we simply give a negative sign, and for being absorbed, we simply give positive sign. So keep it in mind, these two sign conventions are very important while doing problems for different circuits. Okay, and I think it is clear for any electric network, the power, sigma of power or algebraic sum of power in a circuit is equal to 0. That means power being supplied is equal to power being absorbed, or sum of the powers in a circuit is equal to 0. Okay, and coming to the next and last definition, energy is nothing but capacity to do work and is measured in joules. If we want to write the formula which related to power P, simply integrate the P equal to dW by dt on both sides, then we can W is equal to integral some time period T0 to T, P into dt. If we substitute P equal to VA, then this is the formula for the work done, nothing but energy. So that is what I explained earlier in the previous slide, A point and B point. If there is a work done from A to B, that it is denoted by VAB.